Okay, let's start. So last few weeks we done how to differentiate functions. Now today onwards we need to do applications of these derivatives. Applications. So especially tangents and normals. Tangents and normal, part A, there will be question number 7. Tangents and normal. Then part B, question number 14, differentiation question. 14 part A will be graph part. 14 part B will be application of derivative part. Today I am going to complete tangents and normals. Okay. Now see this one first. You consider here x-axis, y-axis. Consider this graph. We call this is function. Say y, say f. Now take general point here, simple x, y. Then we say y equal fx, no? Now you consider a fixed point here. This is variable point P, and here a fixed point A. Consider x coordinate A, y coordinate B. We say that is FB. Okay. Then when you sketch a tangent here, at P, then dy by dx. Here we have function y equal fx. Here function. So when you differentiate dy by dx, we call f dash x. That is meant derivative of y with respect to x. Then gradient, this represents gradient of the tangent. Drawn to the curve at P. That represents gradient of the tangent drawn to the curve at P. Now, here if you consider a tangent here, then when you differentiate, here we have differentiated, no? Dy by dx. When you substitute x equals a, here the notation x equals a, that represents f dash a. Here gradient at a. Here that represents gradient of the tangent drawn to the curve at A. Okay, gradient of the tangent drawn to the curve at A. And here this one we call tangent line. So if we sketch a perpendicular here, we call that is normal, a normal line. So here we are going to find tangent line and normal line equation. There will be question for your A-level examination, part A question, tangent and normal. Then you consider straight line theorems. Here when two lines are parallel, say gradient m1 and say gradient m2. Then we say m1 equal m2. Here for parallel lines. When two lines are perpendicular, you remember here gradient m1 and here gradient m2. m1 times m2 equal minus 1. Gradient product minus 1. When two lines are perpendicular, you say gradient product minus 1. When two lines are parallel, gradients are same. Okay, that's about tangents and normal. Just write down topic. Tangents and normals. tangents and normal. Okay, right. Let a function y equal fx. Let a function y equal fx as the given figure. As the given figure. And a general point on the curve and a general point on the curve capital P within x comma y, within bracket x comma y, capital P within bracket x comma y is a general point on the curve, is a general point on the curve. Capital P x comma y is a general point on the curve. And capital A within bracket simple a comma b is a fixed point on the curve, is a fixed point on the curve, is a fixed point on the curve. Next line, we star mark right now. As the definition of dy by dx, as the definition of dy by dx, as the definition of dy by dx, which represent gradient of the tangent drawn to the curve at a certain point, gradient of the tangent drawn to the curve at a certain point. Certain point. Next line. By the derivative, it is possible to obtain gradient of the tangent drawn to the curve at any point, gradient of the tangent drawn to the curve at any point. Okay, that definition I have given before, but anyway, you put this on again. Here this one again we can denote dy by ds, put bracket, square bracket, put coordinate here a comma b. Likewise you can denote same thing. Here this is the specialty. Here the specialty that what we need to follow. Okay. Now with that one, you see this straight line theorems. Here we have some straight line theorems. Straight lines. Here you consider a gradient m here, line perpendicular to that you say gradient minus 1 over m. Minus 1 over m. Then m1 times m2, m1 times m2 minus 1, no? Then m2 equal minus 1 over m. Then if you need to find gradient of the gradient of the perpendicular line, you take reciprocal and reverse the sign. Reverse the sign. Here, first case. Here, second case, equation of the lines, equation of the straight lines. Then, when you consider here x-axis, y-axis, here we say y-intercept c, gradient m, gradient m. Then that case we write equation y equal mx plus c. Here equation y equal mx plus c. Y equal mx plus c. M is called gradient, c is called y-intercept. Here gradient, c y-intercept. Y-intercept. Okay, this is straight line equation. And further we have equation. So when you consider point on the line alpha comma beta, and gradient is given. Gradient is given. Then here this equation we can write y difference of x difference, y minus beta over x minus alpha. You take any point here, general point x comma y. Then y difference of x difference equal gradient. Then y minus beta equal m times x minus alpha. Here another form of straight line. Another form of straight line. Here x minus alpha. Y minus beta m times x minus alpha. If we know point on the line alpha comma beta and the gradient, we can write y difference of x difference equal gradient. Then this is another form of straight line. Another form of straight line. And when you consider this one and this one, we can write the line in the form ax plus by plus c equals 0. This is equal general form. General form. General form of straight line. So you can write y equal mx plus c format or y minus beta equal m times x minus alpha format. But anyway, if you put all terms one side, we can get general term. This is called general term. General term. Okay. Then this is about straight lines. Straight lines. Okay. Put this note again. Put this note. So in tangents and normals we find straight line equation. So usually this type, y difference of x difference is a gradient. Y difference of x difference is a gradient. This format we write straight line of the tangent, the equation of the tangent, or otherwise we can write that into general form. But sometimes we need vertex form. Here sometimes we need intercept form, slope intercept form. Then by that one we can find gradient and y-intercept. Okay. Now with that one, you again write this. You again write this relation. When you consider your function fx, you take this point a comma b, then we know this one is the tangent. Then dy by dx at x equal a, or f dash a mean gradient of the tangent at a. Here this is gradient and we know point. Gradient known, now point given. Therefore equation of the tangent, we write here gradient, here point. Y minus b over x minus a equal dy over dx at x equals a. So that's how we write gradient of the tangent, equation of the tangent. And thereafter you cross multiply and write in general form. This is how we get equation of the tangent. Then here this line we call normal. So here normal gradient, it is perpendicular. Then perpendicular line gradient minus 1 over m. Therefore gradient of the normal is a minus 1 over dy by dx at x equals a, or otherwise minus 1 over f dash a. Here this is gradient of the normal, f dash a. Gradient of the normal. Okay. Then previous notation you take. By previous notation you can take. Here gradient of the normal at a. Therefore now you write equation of the normal. Then we know gradient and point given. Then y difference of x difference equal gradient, no? Then you write y minus b, I'll write here, y minus b over x minus a equal minus 1 over dy by dx at x equals a. So definitely there will be questions regarding tangents and normal. That's how we go. Okay, put that note as well. Okay, now that's the concept. That's the concept. So when finding tangents and normal, we have working rule. We have working rule. So first one we need derivative, no? First one we need derivative. Then given function, you have to differentiate. You have to differentiate the given function. They have to find dy by dx, subject dy by dx, and there will be point given. Then you take that point and substitute to that dy by dx and find the gradient. Find the gradient. Then we get gradient of the tangent, no? Gradient of the tangent. So now we know gradient of the tangent and we know point. Then you write straight line equation. That is the equation of the tangent. That's the equation of the tangent. And so further, we know gradient of the tangent by derivative, no? Then normal is perpendicular to that. Normal perpendicular to that. Therefore, by the derivative you can find gradient of the tangent. If you say that is gradient m, then perpendicular line gradient we say minus 1 over m. Minus 1 over m. Thereafter you can find gradient of the normal. Now we know gradient of the normal and point given, then you can find equation of the normal. Equation of the normal. Very simple thing, that's the concept. Function can be different. Okay? This function can be different. Function can be polynomial function, function can be rational function, exponential functions, or parametric function, okay? Logarithmic functions. Then function can be any trigonometric function. There can be different type functions, and we know how to differentiate any function. We know how to differentiate any function. Therefore, you differentiate the given function, find dy by dx, substitute and find the gradient of the tangent, write the line, and by that one you can write normal line. Okay, normal line. Then simple thing. Then as I told you, function can be different. Therefore, according to the function, you have to find derivatives, different techniques. So there's special one, parametric. Usually that part A equation comes with parametric functions. Later we will see that. Then when differentiating parametric function, we have x and y. Then you have to find dx by dt. Then y, you find dy by dt. Then if the parameter is t, you find dy by dt and dy by dt. By that one you find dy over dx. Then we can go further, no? We can go further. Okay, let's do few examples. Let's do few examples. Okay, write down this. Find equation of the tangent. Find the equation of the tangent and the normal. Find the equation of the tangent and the normal. Drawn to the curve. At the given point. At the given point. At the given point. Okay. See this one, I'll do a few examples. See this one. Example, y equal x square plus 1 at x equal 1. I'm going to find this. So function given, only x coordinate given. So to find the equation of the tangent, we need gradient and full point, no? Both x, y coordinate needed. Therefore here 1 given, when x equals 1, y you put here 1 square plus 1, 2. Therefore coordinate 1, 2. Corresponding coordinate 1, 2. Now point. Now you differentiate this. Then find dy by dx. It is 2x. Just 2x. Then we need to find the gradient at this point, no? Then by this one you find dy over dx at that point at x equals 1. You substitute here. 2 times 1, 2. Here gradient of the tangent. Gradient of the tangent. Gradient of the tangent at 1, 2. Now we know gradient, then write tangent. Then tangent equation, here point y minus b mean 2 over x minus a mean 1 equal that gradient 2. Thereafter you simplify this. Y minus 2 equal 2 times x minus 1, better write general format, take all terms into one side, I'll get into right side. Here 2x, when you put y the other side minus y, here minus 2 cancel, here equation of the tangent. Equation of the tangent, simple thing. Then here gradient of the tangent, no? Take reciprocal, that is half, and reverse the sign, minus half. Here 2, take reciprocal, half, then reverse the sign, minus half. Then by that one you can write normal. Therefore normal equation, same point, then y minus 2 over x minus 1 equal, here take reciprocal and reverse the sign. Here equation of the normal, here tangent and here normal. Then you simplify 2y minus 2 minus x minus 1. Then you simplify and get the equation. I'll put all terms left side. Here minus x goes to plus x. Here plus 2y minus 4 plus 1 minus 5, 0. Here equation of the normal. Here we convert into general form, that is general thing. Then we need to take all terms one side and better to get x coefficient as positive. X coefficient as positive. That's how we derive. Okay. Do that example. Do that example. Simple thing, huh? The example, see another example. Okay, you better do with me. Y equal x minus 1 over x plus 2 at x equal 2. X equals 2. Then when x equal to, find y. 2 minus 1, 2 plus 2, 1/4. Therefore point 2 comma 1/4. Then differentiate, then dy by dx. Here rational type, no? Then denominator square, denominator times derivative of numerator minus numerator times derivative of denominator. Simplify. 3 over x plus 2 squared. No? Here plus x minus x cancel, 2 plus 1, 3. Then you have to find dy by dx at this point. Put x equals 2 now. Here substitute 2. 3 over 1 over 2 plus 2 squared. Simplify. Here 2, 4, 3, 12. Here 2, 1, 4 plus 1, 5, 25. Here gradient of the tangent. Here the point. Therefore you can write tangents, no? Therefore tangent equation y minus 1/4 x minus 2 equal 12 over 25. And you simplify and get the solution. Then normal equation y minus 1/4 x minus 2, y difference of x difference. Here take reciprocal, 25 over 12 and reverse the sign. Here simplify and get the solution. That's how we get, okay? Complete. That is example 2. X equals 2 here, no? X equals 2, 3 divided by 16, no? 3 divided by 16. Then here 3 divided by 16. Then minus 16 divided by 3. Minus 16 divided by 3. That is tangent and the normal. Continue. Take final answer in general form. Okay, then further check this. Third one, y equal sin x plus 2 at x equals pi divided by 6. Then find corresponding y value. Sin pi divided by 6 plus 2, half plus 2, 5 over 2. Therefore, point pi divided by 6, 5 over 2. No need to put pi equal 22 over 7. No need to write. Just put it as it is. Then differentiate dy by dx cos x plus 2. Then find dy by dx at x equals pi divided by 6. Then pi divided by 6 we put here. Cos pi divided by 6 plus 2. Then cos 30 root 3 by 2 plus 2. Derivative 0. Derivative 0. Okay. Now we know gradient of the tangent, therefore write tangent equation y minus pi over 2 x minus pi over 6 equal gradient root 3 over 2. Then you simplify and get general form. The normal equation y minus pi over 2 x minus pi divided by 6, take reciprocal 2 over root 3 minus. Here is normal and the tangent. Finally, you convert that into general form. Okay, complete. දැන් මේක අර ඉර ගහලා ඔයාලා තියන්න එපා. අර අතනම ඇරෝ එකක් මම ගහුවේ. ඔයාලා සිම්ප්ලිෆයි කරන්න ඕනේ. මම මේක ඔකට සිංහලෙන් කිව්වේ. Now see another example. So our procedure simple, very simple procedure we have. So define derivative, substitute coordinate, write tangent and normal. No? Procedure very simple. Then function can be different, point can be different, but procedure fixed. Then fourth one, consider x squared plus y squared equal root 2 at 1 comma 1. Now here full coordinate given and function given, but previously functions are explicit. No? Now this is implicit now. Why not subjected? But anyway you follow same procedure. Just differentiate first, then 2x 2y dy by dx. Here root 2 derivative 0. Then dy by dx minus x over 2 minus x over y. Then dy by dx at that point. Here previous all cases we had only here x values. No? Now here both we have x and y. That's why I put here square bracket with 1 and 1. Now put 1. minus 1. Anyway, this is gradient of the tangent. Gradient of the tangent. Then you write tangent equation. Tangent equation, y difference, x coordinate 1, y, x, y both 1. Gradient minus 1. Then y minus 1 equal minus x plus 1, x plus y minus 2 equals 0. Then normal equation, y minus 1 over x minus 1 equal minus 1 over minus 1. Then minus 1, x, y minus 1 equal x minus 1, x minus y 0. That's how we get. The specialty here, y not subjected. But anyway, we know how to differentiate. Then you differentiate subject dy by dx, substitute point and find gradient of the tangent. By that one, write equation of the tangent and the normal of the tangent. Equation of the normal. Complete. Okay. Now see another example. I'm changing here function. I'm changing here function only. Then the procedure fixed. 5. X equals t square plus 1. Y equal 2 divided by t. At t equals 1. Now the function given in parametric form. Function given in parametric form. Anyway, you have to find coordinate and you have to find derivative. So t equal 1 given. Then you put t equals 1, or before that differentiate dx divided by dt 2t, dy divided by dt minus 2 over t squared. Then find dy by dx, we need this. That is dy by dt times dt by dx, dy by dt minus 2 over t square, dt by dx, take reciprocal, minus 1 over t cube. Then at t equals 1 given, you find x first. Here find x. 1 square 1, 2. Find y. 2 divided by 1. Again we get 2. You find dy by dx at t equals 1. Then put t equals 1 here. Minus 1 over 1 cube. Minus 1. Then here xy coordinate known, gradient known. Then you can find equation of the tangent and the normal. No? Now you write tangent y minus 2 x minus 2 over minus 1. X plus y minus 4 0. Then equation of the normal, y difference of x difference equal a minus 1 over minus 1. y minus 2 equal x minus 2, then x minus y equal 0. Then function can be parametric or any type function. You follow same procedure. First find dy by dx, then substitute and find gradient of the tangent and normal. Okay, complete that example as said. So usually we get this type of relations, again parametric function relations in your A-level question. Okay, so after that you try to find equation of the tangent and the normal. Okay, I'll give you 5 minutes. One by one you find. Complete. Check your answers. First one, dy by dx 2x plus 1 at x equal minus 1, y equal minus 1 square, minus 1, here minus 1. Then x coordinate minus 1, y coordinate minus 1. Then dy by dx at x equals minus 1, 2 times minus 1 plus 1, minus 1. Therefore, tangent y minus minus 1, x minus minus 1 equal minus 1. Normal y minus minus 1, x minus minus 1 equal minus 1 over minus 1. Minus 1 over m. Fine. Simplify and find it. Then second one, check your answers. Rational type function y equal 2x minus 1 over x plus 1, then dy by dx, denominator square, denominator times derivative of numerator, numerator times derivative of denominator. Then 2x cancel, 2, 1, 3. Here 2, 1, 3. Then at x equal to y value, put 2 here, 2 plus 1, 4 minus 1, 3 over 3, 1. Then dy by dx at x equal 2, then 3, 2 plus 1 square, it is 1/3, here 9. Then you can find tangent and normal. Find tangent and normal now. Then tangent y minus y coordinate here 1, x minus x coordinate 2, gradient of the tangent 1/3. Simplify. Normal y minus 1, x minus 2, and take reciprocal and reverse side. Normal equation. මෙතන මේ 12th එකේ දෙවෙනි එක x කරගන්න. 12th one, second term x. Okay, then third one, y equal sin x plus 2 cos x, then dy by dx, sin derivative cos, cos derivative minus sin. Then at x equals pi divided by 4, y coordinate sin pi over 4, 2 cos pi over 4. Three over root 2. Then dy by dx at x equals pi divided by 4, cos pi by 4 minus 2 sin pi by 4. Here 1 over root 2, 2 over root 2 minus 1 over root 2. Then we know gradient and the point, no? We know gradient and the point. Then you find equation. Then tangent equation y minus 3 over root 2 x minus pi over 4 equal minus 1 over root 2. Then normal y minus 3 over root 2 x minus pi over 4, take reciprocal and reverse the sign. That's the normal. Continue. Okay. Question number 9. Question number 9. Now here exponential type function given y equal 2 times e to the power x plus 3, then differentiate 2 times e to the power x, then at x equal 1 y value find, substitute 2 times e to the power 1 plus 3, that is 2e plus 1, 2e plus 3. Then dy by dx at x equal 1, 2 times e to the power 1, that is 2e. E to the power 1 means e. Then tangent y minus y coordinate 2e plus 3 x minus x coordinate 1 equal gradient 2e. 2e. Simplify, yeah? Then normal y minus 2e plus 3 put bracket over x minus 1 equal 1 over 2e, reverse the sign. Here gradient 2e, take reciprocal and reverse the sign. That is question number 9. Continue. Okay. Then question number 10, parametric type function. Parametric type function. Follow same technique. Then y equal ln t. Then dy by dt 1 over t x equal 2 ln t plus 1 dx divided by dt 2 over t plus 1. then dy by dx, chain rule, dy by dt, dt by dx. Then dy by dt, 1 over t, 2 over t plus 1, simplify, t plus 1 over 2t. Then at t equals 1, find x first, t equal 1, ln 1, log 1 means 0, y, 2, ln 1 plus 1, 2, we can't further simplify. Then dy over dx, at x t equal 1, here 1 plus 1, 2 times 1, 1, greater than 1, x coordinate 0, y coordinate x, 2 ln 2, 2 ln 2, no need to simplify. Yeah? Using logarithms you can find this value, but no need to find, you can put ln 2. Then tangent y minus 2 ln 2, x minus 0, gradient 1, normal y minus 2 ln 2, x minus 0 equal minus 1. That is question number 10. Okay, then next one, again parametric function given, y equal 2 sin theta plus 1, dy over d theta 2 cos theta, x equal 2 cos theta, dx over d theta minus 2 sin theta, then dy by dx, dy by d theta times d theta by dx, 2 cos theta or minus 2 sin theta minus cot theta. Then at theta equals pi by 6, x 2 sin pi by 6 plus 1, then here half plus half times 2 plus 1, 2, then y equal 2 cos pi by 6, root 3 over 2, then that is root 3. Then dy by dx, theta equals pi divided by 6, here minus cot pi divided by 6, then cot 30, 1 over tan 30, root 3, minus root 3, no? Cot 30, 1 over tan 30, root 3. Then we know coordinates and gradient. Then write tangent. y minus root 3 y x y minus 2 x minus root 3 equal minus root 3. Then normal y minus 2 x minus root 3 1 over root 3. Okay, then last one, y equal 4 sin square theta, y equal 4 sin square theta minus 1. Differentiate dy by dx 0.2 sin theta sin derivative cos x equals to 1 minus sin theta dx by d theta 2 sin derivative cos minus cos, here minus, then dy by dx dy by d theta times d theta divided by dx, here 8 sin theta cos theta 2 cos theta minus 4 sin theta minus. Then we have coordinate and we can get coordinate and derivative. When theta equal pi by 4, x equal to 1 minus sin pi by 4. 1 minus 1 over root 2 y, here 4 sin squared pi by 4 minus 1, here 1 over root 2 squared 2 half, 2 minus 1 1. Then dy by dx at theta equal pi by 4, put it here, minus 4 over root 2. Now we have coordinate and gradient. Then tangent y minus 1 x minus 2 times 1 minus 1 over root 2. Gradient minus 4 over root 2. You can simplify. Then normal y minus 1 x minus 2 1 minus 1 over root 2. Take reciprocal and reverse the sign. That is root 2 divided by 4. Root 2 divided by 4. dy by d theta, dy by d theta. Okay, now the concept is fixed, but the function can be varied. Okay. Okay, now let's do past paper questions. Take past paper set. Okay, now from 2011 to 2024 and further, we have differentiation questions, part A, tangents and normals. Part A question will be tangents and normals. Then 14 part A, graph, 14 part B, application. Okay. So here I have given up to 2024 question, but that not include 24 and 23 part A question. I'll give it little later. I'll give it now. Okay, anyway, go to 2015 A level question and read and start. 2015 A level question, part A only. 2015, a parametric form x equals 2 plus cos 2 theta, then y equal 4 sin theta. Find derivative dy by dx, then dx divided by d theta minus sin 2 theta times 2, dy by d theta for cos theta. Then need dy by dx, dy by d theta, d theta divided by dx, dy by d theta for cos theta over 2 into sin 2 theta minus. Simplify 2 cos theta, a minus sin 2 theta, 2 sin theta cos theta. Now simplify minus 1 over sin theta, minus 1 over sin theta, or cosec, you can write cosec theta. Now we have to find normal equation only. We have to find normal equation only at theta equals pi by 4. Therefore, theta equal pi by 4, take x first, 2 cos 2 times pi by 4 cos 90 0. Then y 4 sin pi by 4 1 over root 2 2 root 2 dy by dx at theta equals pi by 4 minus 1 over sin pi by 4, that is minus root 2. Now we know gradient and coordinates. We know gradient and coordinate. Then we have to find only normal. Normal equation y minus 2 root 2 x minus 2. Here tangent gradient 1 minus root 2, then normal gradient is reciprocal with change in sign. Now cross multiply. Root 2y, 2 root 2 times 2 means 4, x minus 2. Take all terms into one side. Plus 2. That's the normal. Same type. Okay. Now you try 2018. 2018. Take time. Okay, 2018, x equal ln tan t by 2. Then dx divided by dt we need here 1 over tan t by 2. Tan derivative sec square t by 2, then t by 2 derivative half. Then sec square t by 2 mean 1 plus tan squared t by 2, here 2 tan t by 2. Then here this relation very familiar, 2 tan theta over 1 plus tan square theta sin 2 theta in trigonometry. 2 tan theta over 1 plus tan square theta sin 2 theta. Then it's reciprocal. No? Then here say 1 over sin 2t over 2 mean sin t. Then y equal sin t dy by dt cos t. Then dx over dt, dy over dt known. Then dy by dx equal dy by dt, dt by dx. dy by dt cos t, dx by dt 1 over sin t. Then sin t cos t. We get sin t cos t. Now t value given pi over 2 to pi range. Here t given range pi over 2 to pi range. T equal 2 pi divided by 3. Why? Now we need to find gradient of the tangent. Only gradient of the tangent need to find. Then dy by dx at t equals 2 pi divided by 3 needed. Then sin 2 pi over 3 cos 2 pi over 3. Then sin 120 half cos 120 minus root 3 over 2. Sorry, here root 3 over 2, here minus half. Then finally minus root 3 over 4. That is gradient of the tangent. Then derivative represents gradient of the tangent. Okay, let's do another one question. 2017, part A. question. Start. Same procedure. x equal 3 cos theta minus cos cube theta. Dx divided by d theta minus 3 sin theta minus 3 cos square theta, cos derivative minus sin. And take minus 3 sin theta outside. 1 minus cos square theta. Here sin squared. Then minus 3 sin cube theta. Y equal 3 cos theta minus cos cube theta. Then dy by d theta, cos theta derivative minus sin. 3 cos square theta, cos derivative minus sin. Minus 3 here y equal 3 sin theta. Sin cube. Sin derivative cos 3 sin square, sin derivative cos, then take cos outside, 3 cos theta, 1 minus sin square theta, we know this is cos squared, then 3 cos cube theta, 3 cos cube theta, then dy by dx, dy by d theta times d theta by dx, dy by d theta 3 cos cube theta dx, d theta divided by dx minus 3 sin cube theta, that means minus cot cube theta. We have to show that, no? And further given, now find the coordinates of P on the curve at which the gradient of the tangent line minus 1. Now gradient given, we have to find coordinate. Then take gradient minus 1. Now dy by dx given minus 1. Cot cube theta 1, cot theta 1. Now theta in between 0 to pi by 2, no? Then take theta pi by 4. Theta given 0 to pi by 2. Therefore, theta value only we have pi divided by 4. Otherwise, we have to write general solution. But range given, then no need to worry about that. You can take directly principal solution pi divided by 4. Find the coordinates. Now you have to find coordinates. Here this is x and this is y. Okay, by that you can get coordinate. Then x comma y, x mean 3 cos pi by 4 cos cube pi by 4, 3 sin pi by 4 sin cube pi by 4. That's the coordinate. Okay. Take that theta value and substitute. Take that theta value and you substitute that. Now simplify. Here 3 over root 2. Here 1 over root 2 cube. 1 over 2 root 2. 3 over root 2. 1 over 2 root 2. Cos pi of 1 over root 2. No? Then take 2 root 2. 6 minus 5. 5 over 2 root 2. Here the coordinate. That's the coordinate. So by the gradient find theta value, then corresponding theta you can get the coordinate. Corresponding theta value we can get the coordinate. Complete. So complete and get interval.